Imagine you're watching an orchestra play. The violins are playing the melody in time with one another, not just because they can hear the beat, but because they can see it. The conductor is using their baton to outline each beat so that everyone can play in time. Now, imagine this same orchestra trying to play the same piece, but without the ability to watch their conductor. It would be much harder for them to play in time. This demonstrates that visual motion plays a key role not only in how we perceive time, but in how we use it to act in the world. If musicians can benefit from conductors, in what other ways can we use motion to improve our behaviors? Now, despite this real-world example, the accepted scientific consensus is that when it comes to perceiving time, our ears are superior. When you ask people to judge time intervals that are defined by brief sounds, like beeps played through headphones, or flashing lights, hearing always comes out on top. Perhaps, though, it isn't our eyes, but rather the way that psychologists like myself have tested them that gives us that answer. Like the example of the conductor's baton, objects in the world don't just appear and disappear. They move. From this observation, I predicted that performance on a time task would be better when the stimulus that defined a time interval was moving, in contrast to that flashing light. In my study, I administered a task where time intervals were defined in 3 different ways. 1 was auditory, and 2 were visual. In the auditory condition, a pair of beeps played to define a time interval, and in one of the visual conditions, a ball briefly flashed on the screen 2 times. And these conditions were congruent with those used in past research. The other visual condition, I designed a new kind of stimulus, a ball that appeared on the screen and then bounced 2 times toward the bottom of the screen to define a time interval. It was in this condition that I predicted performance would be better than with the visual flashes, since the motion of the ball is what defined the interval. The participants in this study completed 120 time judgments across these 3 conditions, where they had to report whether a test time interval was shorter or longer than a standard time interval. Now, in my field, which is called psychophysics, we take this data and use it to calculate something called a just noticeable difference, or JND. In this context, a JND is a value that captures how different 2 time intervals need to be for you to reliably judge them as such. So for instance, if your JND is 100, that means that you can say that a 600 millisecond interval is longer than a 500 millisecond interval about 80% of the time. And crucially, the smaller this value, this JND, the better your sense of time. And the smaller that difference between the intervals needs to be for you to reliably tell them apart. So for each person that came into my lab to take this experiment, I calculated a JND across the 3 conditions and then compared them to see which one generated the best sense of time. In line with prior work, I found that the average JND with the flashing ball was significantly higher than the average JND with the auditory tones, which supported the claim that hearing is the superior sense for time. The bouncing ball condition, on the other hand, dramatically reduced the average JND in contrast to the flashing ball, such that their performance with the bouncing ball was as good as their performance with the auditory tones. This result supported my hypothesis that our sense of time would be improved with a moving visual stimulus. My research matters because motion is everywhere. Not only do musicians rely on conductors, but athletes need to track a ball to make a catch, and drivers even use motion to time their turns and avoid hitting other vehicles. With this empirical result that motion sharpens our sense of time, we can begin to develop better assistive technologies and even find ways to improve coordination in sports and the arts. Motion isn't just something that we see, it's something that actively shapes how we perceive and how we interact with the world. And whether it's a bouncing ball or a conductor's baton, motion helps us stay in sync with the world around us. Thank you.